Here we will talk about homework 11's problem 1. So now we already know that the process xt is a real and wide sense stationary with its autocorrelation is Rxx tau, and also its power spectral density x omega. So first, if we would like to show that the autocorrelation is real and even, so we can see since we already know that it is a wide sense stationary, so the correlation on top is equals to the estimation on x t and tau and x t, and this one, it should be a constant which is real. And second, this one is equals to the autocorrelation between the time, suppose it's t plus tau and times t, which equals to the estimation on these two times production. Change this order doesn't affect the result, so the estimation for can get together, which is equals to change its order as t and tx tau correlation. Here the difference will become negative tau, so it's correlation at tau, which means these two are same, so we can imply that the autocorrelation is even. For the second part, to show the power spectral density as xx on omega is even and non-negative, we can expand it as from negative infinite to infinite. The correlation with Fourier transform d tau. And this one we can expand it as this way. And because we know that this one is even and the sine omega tau is odd, so the total is also odd. And if we would like to change it from even to sine to cosine, and the signal here will the sign here will be changed. So finally, it is equal to 2 times from negative infinite to infinite, or xx tau cosine omega tau and integral on tau. Which is because it's even, so it's also equal to and finally, we can see that the spectral density is also on negative tau. So finally, it's equals to Sx negative omega. So this one we prove that negative omega and 2 omega will have the same power spectral density, so we can imply that they're even. And to show if the spectral density is non-negative, we can suppose that if we input the white stationary process XX into a bandpass filter, and then we got the output as white T, and where the HS is equals to 1 if we select some time from omega 1 to omega 2, and 0 for otherwise we didn't take them as. Then find the estimation of YT square can help us to find its non-negative. So it is we know that the mean square are always larger than equals to 0. And so this one, on the area level, it will equals to the bandpass and the power spectral density. And here, since only the things we can pass, it will equals to 2 pi from omega 1 to omega 2, and so whenever we took any kinds of the omega 1, omega 2, the area of the spectral density is always non-negative. So it is possible for only if it's possible for this the spectral density such that omega is larger than or equals to 0 for everywhere. And we finally proved the problem.